A low thrumming urgency clung to the coastal air as scientists stationed along Florida's Atlantic edge murmured into radios, checked instruments, recalibrated sensors, and stared at the horizon with attention usually reserved for hurricanes. Hours earlier, USGS field teams monitoring a network of coastal elevation trackers had confirmed something they had never seen in this region with this speed or uniformity. The coastline measured across hundreds of miles was rising. Before we start, smash the like and subscribe buttons for more updates. It began subtly enough that the early readings were almost dismissed. Field logs showed a faint but measurable upward shift in shoreline elevation along the central east coast, first detected near Cape Canaveral and then echoed farther south toward Vero Beach. The increase was small, just millimeters at the start, and the initial assumption was equipment drift or calibration error. But as dawn stretched across the water, the anomaly became undeniable. The sensors showed a consistent elevation gain along a continuous stretch of Florida's coast, and not just at one isolated patch. The readings were synchronized, correlated, and rapidly increasing in magnitude. Within several hours, the rise had become measurable in centimeters that triggered the internal alert. When a second independent system confirmed the same trend, the United States Geological Survey issued the level of warning reserved only for severe immediate geological concern, a red alert. The declaration reverberated through scientific agencies, emergency management centers, and the entire network of researchers who had spent their careers studying land subsidence, sea level change, fault stability, and coastal geology. No one had predicted this. Coastlines do not simply rise, not as one unified sheet of land, not within a span of hours, and not with the eerie consistency the instruments were reporting. Something beneath the surface had shifted, and the implications were immense. Specialists connected through secure conference lines, maps spread across digital dashboards, and color-coded readings pulsed in real time. The elevation gain was continuing at an irregular rate, sometimes slowing to nearly a pause, then quickening as if pushed by some unseen force deep below the crust. A process was unfolding, one that none of the participants had trained to witness. Theories were thrown across the table in rapid succession. Some experts proposed a slow-moving tectonic rebound, perhaps triggered by seismic strain released deeper beneath the North American plate. Others suspected a regional pressure change within the karsted systems that riddled Florida's subsurface, those vast limestone cavities carved by eons of groundwater. But these hypotheses did not fully align with the observed data. The uplift was too broad, too cohesive, too synchronized. The coastline itself began to exhibit early physical signs of the rise. Beaches subtly narrowed, not by erosion, but because the sand appeared to be inching upward relative to the tide line. Sea walls that normally faced gentle waves at high tide were beginning to sit perceptibly higher above the water. Docks looked strangely elevated, as though their pilings had grown overnight. Small discrepancies that only the keenest observers would notice at first glance, but when paired with the data, everything pointed to one conclusion: the land was moving. Teams ventured out aboard survey boats to verify with laser scanners and manual instruments. What they found confirmed the alarming reality. The uplift was real. It was active and it was continuing. The USGS Red Alert was not merely a notification, it demanded immediate scientific mobilization. Helicopters shuttled specialists to monitoring hubs along the coast. Military satellites were redirected to capture high-resolution topographic imagery at rapid intervals. Geophysicists were rushed to Florida from around the country, called from conferences, research labs, and university campuses. The suddenness of the event broke through the usual bureaucratic rigidity, replacing it with the urgency one might expect during a volcanic eruption or an imminent earthquake. Yet this was neither, it was something else. One of the most confounding aspects was Florida's geological profile. Unlike regions positioned along active tectonic boundaries, Florida's crust is known for its relative stability. There are no major active faults running beneath the peninsula. Earthquakes are exceedingly rare and generally mild. Volcanic activity is non-existent. Even vertical land motion tends to occur at rates measured over decades or centuries, not hours. The uplift along the coastline violated every known pattern. It was as if the Earth had reconfigured the rules overnight. Researchers compiled historical data sets, hoping to find any precedent. Satellite altimetry, seismic records, GPS cushion logs, and marine surveys were cross-referenced with the current readings. None of it provided a satisfactory explanation. The coastline was rising in a pattern that mimicked a slow, controlled swell, smooth, continuous, almost deliberate. Hydrogeologists began focusing on Florida's vast aquifer system. Could sudden pressure changes within the Florida aquifer be pushing the land upward? Groundwater had long carved immense caverns beneath the surface, leading to the state's notorious sinkholes. But uplift, that was uncharted territory. Even if pressure increased regionally, the scale required to lift hundreds of miles of coastline in unison would surpass any known geological mechanism tied to aquifers. Yet, the idea couldn't be dismissed outright. Something beneath was shifting with an intensity that defied conventional logic. Drones maneuvered along the coast, capturing footage of beaches, marshes, mangroves, and barrier islands. The imagery showed striking patterns. Marsh grasses tilting at new angles, mudflats exposing small ridge lines that had previously been submerged, and shallow water sandbars arching upward like the backs of waking creatures. To the untrained eye, it might look like nothing more than unusual low tide, but the scientists watching the live feed understood the gravity. It was the land itself rising, carrying all its ecosystems with it. At field stations, researchers examined seismographs for faint signals. For hours, the graphs showed only subtle tremors, nothing approaching the kind of seismic violence that would typically accompany such vertical motion. The uplift appeared eerily quiet. That alone deepened the mystery. For land to move, energy must be involved, yet the Earth was offering no audible clues. The silence was the most unsettling part. It was as though some deep force was at work, but moving with a patient stillness that didn't match the urgency of the data. As noon approached, reports came in from additional coastal regions. The rise was not confined to the central east coast. Portions of the Keys and sections near the Gulf side of the Everglades showed micro-changes that matched the pattern. This broadened the suspected event radius dramatically. What had been assumed to be an isolated anomaly now appeared to be a regional geological phenomenon too expansive to dismiss as local subsurface pressure change. Geologists began re-examining an old question. Could Florida's entire peninsula be undergoing uplift? The very idea was staggering. Such a process would have far-reaching consequences across ecosystems, water tables, coastal morphology, and the delicate balance between land and sea. A peninsula rising, even modestly, could alter everything from drainage patterns to storm surge behavior. But what mechanism could lift such an enormous slab of crust with cohesion and at speed? Attention turned to the possibility of mantle dynamics. Could a deeper mantle plume or buoyant force be affecting the lithosphere? Typically, such mantle processes evolve over millions of years, yet the improbable had already manifested in the data. Uplift occurring over hours. Even so, some researchers argued that perhaps the event was the culmination of decades or centuries of deep processes that were only now reaching a tipping point. Others were hesitant to attribute such rapid change to mantle behavior without seismic evidence. But with each hour, the land rose a little more, and theoretical boundaries were being redrawn. Coastal residents unaware of the scientific frenzy unfolding behind the scenes began making their own observations. Fishermen returning from early morning runs noticed that the familiar alignment of docks felt off. The tide charts didn't match what they were seeing. Some reported that channels they navigated daily appeared slightly shallower. Beachgoers observed that certain stretches of sand felt broader, lifted subtly above where the waves usually reached. These were quiet reports at first, shared between neighbors or posted in local online groups, but they were consistent with the instruments.